Well, good evening, everyone. I'm Brandon Stevens. I'm your 4-H electric superintendent here for Tippecanoe County 4-H Electric Project. Thanks for joining me tonight. I'm going to record our session tonight so that everybody can rewatch this if they have any questions. And also, if anybody wasn't able to join us, they can watch it in a future time. So I'll share that with you guys, and then also anybody that would like to watch it in the future. So everybody here is for Division 2 for the Shake Light, the magnetic powered flashlight. And I'm going to cover a few things tonight just to get us started and start thinking about what we're going to be building and what it takes in order to build the project. And I've got 30 minutes scheduled, but probably won't go that long tonight. We'll just cover a few things to get you started here. And if anybody has any questions, please feel free to ask them at any time. We've got a smaller group here. And I think everybody's microphones muted. You can unmute them yourself and to ask a question. If you've got a question that you might think would be helpful for everybody, please do that. If it's something else that you'd like to email me or call me and talk about your project later, I'm also available for that. I've got a PowerPoint presentation here that I'll share with you here to kind of start things, and I'll kind of go back and forth so that everybody can take a look at that. And we'll get started here. So let me take a look at sharing that screen with you here. Okay, can everybody see my screen there?
Yeah.
Okay, so we're going to learn about electricity here. And again, I'm going to just take 30 minutes and probably not that long. If you have any questions, my contact information is in the handbook. And you've got my email that you can also email me. Feel free to call anytime to ask any questions about your project. And we'll work again in the future on another workshop here so we can go through and do the assembly process. I also do have a YouTube video of the assembly process that I can share with everybody about the assembly process. And it's also a PowerPoint slide that you can go through and you can watch it at your own pace and stop it, or come back and we'll do another workshop here on Zoom. And we'll go through the assembly process in person also. So we'll have it available multiple different ways for you to be able to assemble your project and learn about that. Okay, and also again, if you like to ask a question, just unmute your microphone so that you can ask a question here. And then when you're done, mute it again so that the background noise doesn't interfere with the other participants here. So we're going to talk about the magnetic flashlight that we're going to be doing. And we've got several different parts that are within the magnetic powered flashlight that allow us to build this. It's an electronic device, but it's more focused on the powering of the device using a magnet and how to generate electricity using magnet. So we've got several different parts here that are available within that device that we're using. So the first one is the coil. Then we've got the diode, the resistor, the capacitor, and the magnet. So let's talk about each one of those parts here for this. So the coil, that's our most important part of the device. That's our power plant, or the electrical generation part of the project. So the coil is a donut-shaped device. It's a special wire that's wound around in a little bobbin or a spool. And this wire that is wound around there is a special wire we call magnet wire. Now, it's not magnet wire because it's magnetically attracted to other metals, but it's called magnet wire because we are using it to produce electricity by passing a magnetic field through it or around it, okay? And this wire is just like normal wire that you used on your Division 1 project, except for it's very fine. And instead of having a rubber or a plastic insulator on it, it has a clear or a red varnish that provides the insulation for the wire. So we can't just take bare copper wire and wrap around in a circle, because if we did that, it would just be one lump of metal, and that would not produce a good field for the magnetic field to pass through and generate the electricity. So this special little wire here is going to be wrapped around your outside of your tube of the flashlight. And if any of you saw the flashlights at the fair last year, you've seen that little black bobbin on there that's the coil that's on the tube, and that's where the magnet passes through. Any questions about that coil or the special wire that we use? Does anybody know where or in town here any company that makes magnetic wire? Have you ever heard of Ray Magnet Wire? There's a company right here in town that's what they specifically produce is magnetic wire that's used in all kinds of devices. Do you know of any other devices that uses magnet wire in them? Can anybody guess of any devices that uses magnet wire? You've all got something in your house that uses magnet wire. What is it? Don't forget to unmute your microphone if you got something you can tell me. Nobody can guess anything? Well, in your house, everybody's got a washer and a dryer. I bet you hate doing laundry. Okay. Inside that washer and dryer, there's a motor, and any type of motor has a winding or a magnetic field that makes the motor spin. So all these motors are wound with magnetic wire. Okay. Another device, if you've got a old style doorbell, okay, you have to be careful because some of you have these new Nest or Ring doorbells that are electronic, and they don't have a little um, uh, I guess, a plunger that dings the bell. The older doorbells had a little plunger that would come out and hit a little metal bar and make the chime. And so in my house, I don't have one of those little chimes that hang there. It's a electronic chime that just makes a sound out of a speaker. But the older doorbells or the buzzers had some kind of magnet wire, a little coil that would make that little plunger go out and hit the little metal bar and make a ding. And that's, I would have two bars that would go ding dong, okay, or maybe the back door just goes ding. So that metal bar has that plunger that's moved by the magnetic wire that's wound around a little plunger. We'll have to get some little pieces and dissect them and take some pictures to share with you. So that's what the magnet wire is in your home. You might have some other types of devices, maybe some transformers or some other devices that use magnet wire to transform, but those are the most common that I mentioned, the motors. Everybody's got a motor of some kind in their house, got lots of motors probably. Now, our other device that we've got within our shake light or the magnetic powered shake light is a diode. So this device is what we call a semiconductor. It conducts some of the time. Semi is partly, and conductor is what we learned in Division 1. It allows electricity to flow. So it allows electricity to flow sometimes. So this is what changes our AC electric that is produced in the coil and makes it into DC electric, which we're going to use to light up our light. And this electricity is flowing through this diode that makes it a DC voltage. Okay, so we're actually transforming the voltage from an AC waveform to a DC waveform. Okay, and we talked about last year, if you did the activity in your book, about AC electric and DC electric. Does anybody remember AC electric in your homes? So in your home, all the lights, the motors, those devices are called AC, or alternating current electric. Okay. This has a positive voltage and a negative voltage. Everything in our homes that has something that plugs in, like our lamp, is an AC voltage. Things that contain batteries, like your phones, your laptop, your iPads, any kind of device that has a battery, is powered off of DC. Even though you plug them into the wall, it's actually transforming the voltage into a DC voltage, okay, so that you can unplug it from the wall and utilize that device remotely without having it plugged into something, and that's a DC or a direct current device. So we're generating the AC voltage using the coil, and then we're transforming that voltage into a DC voltage using the diode. Okay. Now, another important device in our circuit that we're going to be using is a resistor. Does anybody know what a resistor does for our circuit? What does the term resist mean?
It means this like control the current in the electricity.
Okay. And so it slows things down. And if you can think about it like a water hose, when you step on the water hose, it slows down the water coming out of the end of the hose. So it slows down the current in our circuit. So the resistor is going to allow us to just put out a little bit of electricity. We don't want to put everything out all at once. Think of it like a fire hose. You put a bunch of water at once and it uses up. So if you have a 5-gallon bucket and you put a fire hose on it, it's going to use all that energy up really quick. And if we have a fire hose, it's just going to drain that energy as quick as it can dump out of the bucket. If we have a little tiny hose, maybe like a little pinhole that's feeding the water, that's going to resist that water from coming out, and it's going to last much, much longer. And so we're going to use a resistor in our circuit in order to slow down the electricity that's coming out of that power device, our coil, and our capacitor in order to make the light stay lit for a long time. Okay. Now that brings us to the next device, call it our capacitor. So our capacitor, we have capacitors in all kinds of things. Our capacitor in our circuit, this device is going to act like a rechargeable battery. So we don't want to have to shake the flashlight all the time to make the light stay lit. We're going to have that capacitor in our circuit that's going to act like a reservoir. Now, a capacitor is not a very good rechargeable battery, but it will hold charge for a minute or so. Okay, so it's going to be seconds to minutes, not minutes to hours. Okay, so our capacitor is going to be able to store up a charge for maybe 20 seconds, 30 seconds, 60 seconds in order to provide energy to keep that light lit up for a little bit of time, and which require you to shake the light more often in order to keep the light lit. And then our last device here is the magnet. That's our most important part. This is what causes the magnetic field to build and collapse each time the magnet passes through the donut or through the coil. Okay, so each time that magnet passes through, that's going to produce a buildup of current, and then when it exits, the field collapses and it produces that electron flow within our circuit. So that device is going to give us the electrical energy along with the coil. Now, for our next workshop here, we're going to need you to do a couple things in order to get ready for the workshop. And I understand that the extension office is not going to be open until probably the 5th or 4th of May, which is our Monday. So the 4th of May, it may be open on Friday, May the 1st, but we'll schedule another workshop after the extension office is open and allow you to get your kits. Has anybody already bought their kit? Yeah, we got one. Okay, so a couple of you still need to buy your kit. So yeah, we'll want to go back and buy our kits so that we can do that. Okay, let me make sure that I'm not missing anybody else in the meeting here. Okay. And then also you're going to need a soldering iron in order to put your project together. And you may already have a soldering iron at home. And if not, you can buy them online, or you can buy them from my store here at einabox.com. And if you need to pick them up here, I'm in town, you can select to pick that up in person. But you will need a soldering iron in order to solder the parts into your circuit board and assemble them together. Since we're not meeting in person, I won't have any soldering irons that usually I have at the workshop, but you will be able to get one and be able to assemble your project with that. I would suggest this little pencil style so that it's something small and it's easy to handle, and it's not very powerful, so that you won't have to work very fast. You can have a little bit more time, and it's a little bit more forgiving with the smaller wattage. So a 30 watt or 25 watt soldering iron is ideal for that. And if you have any questions about that, you can either email me or call, and I can direct you. Like I said, some of you may already have a soldering iron at your home with you working on other projects, and or you might have somebody you can borrow one from. And if not, you can always buy one from any kind of online electronics distributor or here from EE in a Box and get that information or in that tool that you need. And also there's a book here that you'll want to pick up at the office. I'm going to ask and work on the Division 1 is online as a PDF, and I believe the Division 2 should be available online also, but tonight I could not find that book online, so I'll ask to see because it may be available for download, and if not, you'll have to be able to pick that up at the Extension office. And I'll be able to present some information on the assembly process. I'll share that through an email again. There's some information that you can watch and build that circuit using that presentation, or you can come back to the Zoom presentation when we do our future workshop here and assemble your project and ask questions through that workshop in the future. Any questions from anybody here? Okay, if not, that's everything that I've got for tonight. And I want to thank everybody for joining us for that workshop tonight. And I hope that everybody is able to get your kits here from the Extension office in the next week or two when it opens back up, and everybody's staying healthy and safe. And we will be in touch, and don't hesitate to email or call if you have any questions.
Thank you.
Thank you.
Thanks again, guys. Bye-bye.
Thanks.
Thank you.
Let's close it out.
Oh, look, top left where it says. There you go.